Okay, now listen, the next topic that we'll be discussing is something called trapezium. It's a continuation of that similarity only. So yesterday we discussed about this. We talked about how to go ahead and find the corresponding size proportional and then how to find the different size. This was the question that we discussed yesterday, isn't it? Where we talked about how to prove them similar, then how to go ahead and find the different sides using the corresponding size proportional, and then how to go ahead and find the ratio of the two areas, and then supposing if the area of one triangle is given, how do we find the area of the other triangle. So that is what we've done. Now it's a continuation from here, so we move one step ahead from here, and the next topic will be trapezium. So what will be trapezium is like, look over here, this is the main figure that we had yesterday, so it's the same figure. So now over here we were only saying that there were two triangles, but in reality now we have three figures in this particular question. So we have the upper one, this one, as the small triangle, that is ABC. Then we have the big triangle, that is ADE. Then supposing from this big triangle, if I just remove this portion, if this only the upper half gets removed, so then if from this big triangle, if the upper half gets removed, then I'm only left with this particular portion, because we have removed this particular portion has been removed. So if I remove this, we are only left with this particular figure, and this particular figure is called a trapezium. So ideally we have three figures. We have a small triangle, we have a big triangle, and if I remove, or if I just cover this triangle, that means we are left with the trapezium. Okay, so that means now if I want to find the trapezium, so that means from the big triangle, if I take this off, if this small triangle is removed, we get the trapezium. So the formula that we can write on the basis of that is area of the trapezium. So if you want to find the trapezium, so what we have to do from the big triangle, if I just remove the small triangle, so that means it is area of the big triangle minus the small triangle. So if the small triangle is out, we are only left with this figure, and this is called the trapezium. So area of the trapezium is area of the big triangle minus area of small triangle. So supposing now, let's say there is an example. Supposing if they've already given to me in the question that the area of the big triangle is 5x. So where do we get this from? It's just an assumption. Let's say supposing it's already given to you. Okay, similarly area of the small triangle is this one. So these two are already given. So let's say it's already given to us in the question. Then how do I find the area of trapezium? We apply this formula. Area of the big minus area of small, that will be 5x minus 2x, because the big triangle is 5x and small triangle is 2x, so that is equal to 3x. So that's how we find the area of the trapezium if my value of the big triangle and the small triangle. So if I know the answers or the values of the big triangle and the small triangle's area, I can easily find the trapezium's area by subtracting the two of them. Okay, clear? So now let's say in this one we've already found out the area of the big triangle as this much, area of the small triangle this much, and then I use these two to go ahead and get my area of the trapezium, that is this. So now if the question says find the area of the big triangle by the area of the trapezium. So if this is the question, that means they're asking us to find the ratio of the area of the big triangle by the trapezium. How do we find the ratio? So area of the big triangle, so we take the help of these three information. Okay, area of the big triangle, it's already mentioned as 5x, so we write it as 5x. Area of the trapezium, we got it as 3x, we write 3x. So this x and x gets cancelled, we are left with 5 by 3, so ratio is 5:3. So that's how now I need to get the answers of the big triangle, small triangle, and the trapezium. Once I get the answers of the big triangle, small triangle, and the trapezium, we can easily use those values to get the ratio of the big triangle and trapezium. Or sometimes they may ask us to find the ratio of the small triangle and the trapezium. So let's say same question, if they say now do this, then small triangle, I check what the area of the small triangle is, we just put the value, that is 2x, and what is the trapezium is 3x. So we get, again, x and x gets cancelled, we get 2 by 3, so the ratio is 2:3. Sometimes they may say area of trapezium by area of big triangle. So if they say if trapezium is at the top, then we write trapezium is how much? 3x, so we put 3x at the top. What is the big triangle's answer? Big triangle's area is how much? 5x. So it's not always trapezium will be at the bottom, it can be at the top also, and we get 3 by 5, so 3:5 is the ratio. Okay, now the original question had all of this was the main triangle, and this was what was the question, all these things, isn't it? And now, so let's talk about the same question. Let's say we do talk about the same question in this question. So when we were solving this, first we had to prove them similar. We proved them similar, then automatically the third pair of angle is equal. Once the third pair of angle is equal, then the corresponding sides are proportional, and then we use any two of them to get all this. Okay, and then to get the ratio of the area of the two similar triangles, we had to take the square of any one pair of the corresponding sides. We took this, and then we got this as the answer. So now for the trapezium also, what we have to do, if they say any question that is related to trapezium, we have to first go ahead and get the ratio. Till the time we don't get the ratio of the two similar triangles, we cannot do any question based on trapezium. So over here we have 1/4. So now I'll use this. So we have got area of triangle ABC by area of triangle ADE is 1/4. So we have to first get this, and only then now we go ahead and get the answers based on your trapezium. Now trapezium, so if I somehow get the area of the trapezium as this, area of the small triangle this, so if I get this, then I can easily get my answer of trapezium. And once I get the big triangles area, small triangles area, and the trapezium area, then we can find the ratio, anything. So how do we get the area of the big triangle, how do we get the area of the small triangle and area of trapezium, so that we can get the ratios? That is what I'll teach you. So this overview was already given, but now how do we get this? That is what I'll explain you. So now once we go ahead and now we get the ratio. So ratio is area of triangle ABC by area of triangle AD is 1/4. That is already, we had already got this. Now once I get this, then to get the areas of the big triangle, small triangle, what we have to do is, now at the top, what do we have? We have area of triangle ABC. So now we say, we assume, so we say let the area of triangle ABC is whatever is this value, just put an x next to it. So we write 1x. If this ratio had been 5 by, let's say 12, then my area of triangle ABC would have been 5x. Okay, if it had been 3 by 8, it would have been, area of triangle ABC would have been 3x. Okay, so now in this question it's 1/4, so we say this is 1x. Area of triangle ADE is 4, so we write 4x. So once we get the area of the triangle ABC and ADE, we know ABC is the small triangle and this is the big triangle. How do I know? Just by looking at the values only, I know it's the small and big. Now area of trapezium is equals to the bigger triangle minus the smaller triangle, that is 4x minus 1x is equal to 3x. So that is how we get. So how do we get the area of the triangles and the trapezium in terms of x? For that we need to first get the ratio of the two similar triangles. Okay, so once we get the ratio of the two similar triangles, then whatever is the value, we just have to assume the area of the upper one in terms of that value into x, and the lower one is that value into x, and then we subtract the two of them to get our trapezium. Clear? And now once we've got the values of the trapezium, the area of the big triangle, the small triangle, and the trapezium, so let's say the question says find area of triangle ABC is to area of trapezium. So area of triangle ABC, so area of trapezium. Now we can write the ratio first initially in terms of a fraction. So we'll write area of triangle ABC by area of trapezium. ABC, we have already got the area to be as 1x, so we substitute as 1x. Trapezium, we've already got it as 3x, we write 3x. So x and x gets cancelled, 1/3, so the ratio is 1:3. Now let's say the next question is, they may say in the same figure, they may say now find the area of the trapezium is to area of triangle ADE. So this can be written as area of trapezium by ADE, because the first becomes the numerator, second becomes the denominator. Area of trapezium, what have we got? It's 3x, so we write 3x. Area of ADE, what have we got? ADE is 4x, so we put 4x, x and x gets cancelled, we get 3/4, and the ratio is 3:4. So that's how we go ahead and solve the questions based on your trapezium. So if I want to solve any questions on your trapezium, you have to first go ahead and get the ratio of the two similar triangles. Only then I can assume these areas of these triangles in terms of x, and once I subtract the bigger minus smaller, then I get the answer of the area of trapezium. And then once I get the three of them, I can go ahead and get the ratio of any triangle is to trapezium, or the trapezium is to any triangle. Okay.